Hi, so in this video I'm going to talk about assigning the electron configuration for a particular compound. So the electronic configuration is assigning the orbitals in which the electrons exist. And this is based on the periodic table and the SPD orbitals. So I'll go very simply into the introduction to it, and then I'll look at the different ways that you can represent the electronic structure. So first of all, with our periodic table, if I was to draw a very basic diagram, this is kind of how it sits. This is our S block. This is our P. And this is our D. So I'll just do SPD. So when you're looking at a particular element, so let's look at fluorine. This is element number 9. So it sits over here on your periodic table and it's number 9. So it's in the periods. You've got your first period, your second, your third, your fourth, and it goes down to your 7th period. So it goes down to your 7th period. So I'll just go over the top, S, D, and P. So I'm looking at element fluorine here. So when I'm assigning the 9 electrons, I look at the position of where it is and I can count across on the periodic table. So I've got my 1 S block and there's hydrogen that sits over here, and then helium can sit over here or over here depending on where and how your periodic table is drawn. So, but you've got two elements depending on where helium's sitting. So that completes your 1s. The next, so that's your first 2 electrons. They sit in the 1s. Your next 2 electrons, so we're getting to 9, it sits in that 2s block. And that s electron electronic orbital can only hold 2 electrons. So when we go across further, we're now getting into our P's. If you count across on your P, there's 6 blocks. So there's 6 blocks, 6 elements across. In your S, it's always 2 across. Okay, and depending on where this one is, that may change for that 1S. With your D's, if you count across, there's 10. So there's 10, there's 6, and there's 2. Now, each orbital, so there's 6 for your P's, there's 10 for your D's, and 2 for your S's. So each orbital can hold 2 electrons. So there's 1 S orbital, there's 3 P orbitals, and there's 5 D. So now I've got my first 4 electrons, I've got 5 more. They will be in my P block. So still in that second energy, I've got P, P, P to represent my 3 P orbitals. When I fill it up, I put 1 in each of them and then I double it up. So I'd go, I've got 2, 4, 5, 6, 7, 8, 9. So it'd be 1s2, 2s2, 2p2, 2p2, 2p1. So this is the full electronic diagram, configuration. I like the diagram better. So with the diagram, you put your little box, you write that's my 1s orbital, this is my 2s orbital, this is my 2p. These are degenerate, they've all got the same energy. There's no favorite orbital out of those 3. So when you're filling it up, you put 1 in each and then you double back. So we've got 1, 2, 3, 4. Notice I'm doing a 1-headed arrow up and then a 1-headed arrow down. That's indicating opposite spins on those electrons. And 1-headed arrow represents 1 electron. So we've got 2, 4, 5, 6, 7, 8, 9. So that would be my orbital diagram. Okay, so my full electronic configuration, my orbital diagram. So I'm going to work on something that's in the D block, so a little bit further down on the periodic table. Okay, so I'm going to look at CR, which is element number 24. So when I'm filling this out, I might do the orbital diagrams because they're my favorite. So 1s, 2s, 2p. Okay, so when I fill this out, it's 1s, 2s, 2p, 3s, 3p, 4s, 3d. So looking at my table, I've got my 1s, my 2s, I've got my 2p, then I've got my third energy level, so 3s, and I've got my 3p's, and then I've got my 4s. My d's, even though it sits in that fourth energy level, it actually has the value of that third energy level. So when you half fill your d orbital, it will drop in energy. So if you can promote s electrons up to the d orbital to half fill it, so to get 5 electrons in there, that is what's going to happen. When it completely fills, then it's going to drop even lower and it will sit well within that third energy level. So let's look at CR. There's 24 electrons. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So it sits like this. Now this is what it comes out when you draw it out, but the reality is that because this is a 3D, it wants to promote one of those 4s electrons into the 3D so that it's got an overall lower energy. So this is how you'd normally fill it, but then seeing that it only needs one more, I can take that from here. I would put that in there and scribble that one out. And that would be the correct electronic diagram or orbital diagram for CR.